Hi everyone, welcome back to our final episode in this series, Foundations in AI Machine Learning Lifecycle series. I'm Ava.
And I'm Aniakan. So last time we explored feature engineering and showed you how to build a predictive model using XGBoost in SageMaker. Today, we talk about what happens after you have trained your model, and we wrap up with tips for success on the AWS Certified Machine Learning Engineer Associate exam.
That's right, Anieka. But before we jump into that, let's just remind everyone about the data processing phase in the machine learning lifecycle.
Yeah, absolutely. The data processing in machine learning, that involves two main steps, right? First, we have data collection. And data collection, this is gathering the data, gathering the raw data that's needed for your project. Also, we have data preparation, which involves data pre-processing, cleaning and organizing the raw data, and feature engineering, which primarily creates new variables, new meaningful variables from the existing data.
That's right. And it is important to note that whatever data processing steps you apply to your training data must also be applied to any new data during inference.
Yeah,
And this is going to ensure consistency between how your model has been trained and how it processes new information.
absolutely. That's a great point. Very cool.
Very nice. And now back to what happens after you have trained your model. Let's break down model evaluation first. When you're evaluating your model's performance, you're going to look at different metrics depending on the problem type.
Yeah, that is right. We can say, for example, for classification problems, accuracy, precision, and recall, they can be used for that. Though they measure different, they have different, or they provide different insights. They would all be useful. For example, let's say we want to predict customer churn. Right? We would use those three metrics to help us with that.
That's great. Good point there. And then we have regression type of problems like predicting house prices. And in this case, we look at different metrics such as the mean squared error or RMSE. SageMaker, by the way, makes it really easy to calculate those metrics.
I was wondering about that. All right. So once we're happy with our model's performance, we need to deploy it. And SageMaker gives us several options for that. So the most common is setting up a real-time endpoint for immediate predictions.
And that is when the real work really begins, right? Monitoring. Well, it is all there is a lot of work, but monitoring definitely is real work as well. What do you typically watch for during this phase, Aniakan?
Yeah, the big one is model drift, right? Which is the gradual drop in a model's performance, accuracy, as real-world data or its relationships to outcomes shifts. So SageMaker Model Monitor can be used here to detect this automatically.
Yeah, and this is crucial. We also have CloudWatch, which helps us track things like endpoint performance and then prediction latency, right?
That's exactly right, Ava. Yeah, you can set up alerts, right? If something doesn't look right, something looks off. For example, if your model suddenly starts making unusual predictions or if response times spike.
Oh, yeah, that's right. I think our viewers would find it helpful if you explained what a typical monitoring setup might look like.
Absolutely, yeah. Let's take a look at that. So think of model monitoring as a safety net, right? Right. You've got model monitor checking your predictions. Um, Give me a second. Then you have CloudWatch, for example, tracking metrics. That's what it does. CloudWatch tracking metrics, and then maybe there's some Lambda functions. right? Lambda functions to automatically respond to issues like um, if you need to retrain the model. So you would kick off, you'd have CloudWatch, I'm sorry, you'd have Lambda kick off something like SageMaker pipelines to retrain and redeploy the model when drift is detected.
Uh-huh. And also, don't forget about the retraining schedules. How often do you recommend updating models?
Yeah, and I'm going to model my inner consultant here and say that it depends, right? It
Nice.
really depends on your use case. There are general guidelines that say, for example, for high velocity domains like retail recommendations, you might retrain more often, right? Hourly or daily. Um, and for more stable problem domains, retrain less often, weekly or monthly or even longer. And you can also let your monitoring metrics guide you. You've instrumented drift alarms in CloudWatch, and then you retrain on demand whenever thresholds are breached.
That's right. And then we also have some cases where the schedule might be driven by compliance regulations, right, Aniakan?
Yeah, that's a great point, Ava.
Okay, great. And any other points to share here?
Yeah, I'd say start conservatively and then adjust. Right, that is, start with a well managed, um, well understood, take that approach, and then use monitoring data to inform any adjustments that might be needed. Then make incremental improvements based on that real world observation, and always test your monitoring in a development environment. Also remember the machine learning life cycle, right? That life cycle isn't linear; it's an iterative process.
Yeah, that's such a great point. You will often find yourself moving back and forth between phases as you refine the model and respond to real world performance. And Yekan, now that we have touched on all the phases of the machine learning lifecycle, how about some exam tips?
Mm. Yeah, very cool. Yes. Yeah, we definitely have some to share, right? So
Yeah.
yeah, the for the exam itself, success lies not just in what you know, how you approach the question matters. And so we've taken these tips that we're going to present from AWS's own guidance. Let me put it up. Okay, so all right, let's start. Let me start with first one, read the entire question carefully, right? Very important to spend time reading the question. Obviously, you don't want to spend too much time, but yes, definitely read it carefully. Watch for qualifiers like most or least. You know, for example, most suitable or most efficient or least expensive or least time consuming. Also, watch for technical contrast like real time versus batch. Uh, Managed versus self managed. These often point to the correct answer by precisely defining the scenarios, constraints, or requirements. Then next one is map to the right machine learning lifecycle phase. Right. So does the question hint at one of the ML lifecycle phases? You know, for example, the question talks about gathering data. You might think data collection phase. If it talks about um, cleaning or transforming, that might be, you know, where you're looking at the data preparation phase. If it talks about creating new variables, that might be feature engineering. So use that to narrow the choices. Third, consider scale, complexity, and cost. So simple use cases might need Lambda. Heavy ETL would favor services like Glue, and specifically Glue with job bookmarking.
Great tips. Great. So let me also share a couple other ones that are worth considering. Eliminate absolutes. AWS avoids never or always. Options with absolute are seldom going to be the correct choice. Also, apply well architected principles. So, scalability, reliability, cost optimization. These often will tip the scales to the right question. What else? Practice with real labs and sample questions. Hands-on skills in Data Wrangler, Glue, S3, and SageMaker will solidify your understanding. Always be conscious of the cost implications of those. Just to mention this here. And then use the process of elimination. I really like doing this. So if you're unsure, go ahead and rule out two wrong answers first to boost your odds.
I love it. 50-50.
So let's see exactly. So let's see how these techniques can be applied to a couple of practice questions. You ready, Aniakan?
I'm ready. Let's do it.
All right. So I'll go ahead and read the first question we have here, sample question. A retail company processes daily sales data for machine learning training. They need to clean the data set, remove the duplicates, impute missing values, and perform one hot encoding on categorical fields every morning. Which solution is the most cost effective and requires the least operational overhead?
Okay. So Eva, let me take a swing at this. So the options are AWS Glue ETL job with ETL with job bookmarking. Yes. And then two, we have SageMaker Data Wrangler Flow. We have Apache Spark on an EMR cluster and custom Python script running on an EC2 instance. So right off the bat, we see the qualifiers. We see most cost effective, right? In the question stem, we see most cost effective. We see least operational overhead. So keep an eye out for a serverless managed service, right? That maps to the least operational overhead, and also one that only runs when needed.
Yeah, great. And this is squarely a data preparation scenario, right? So option
Yeah.
one is going to be glue. What do you? Well, let me give it back to you. I was going to go over some
Yeah,
of the
no, please
questions.
go ahead. Yeah, I like
No,
where you're
you
going
go
with
ahead.
that.
Go. You
Okay,
you were going to answer. Go for it.
okay, all right. Yeah, okay, yeah. Option one, yeah, yeah. AWS Glue ETL with bookmarking. You're right. That is definitely the winner. It's serverless. It auto scales, and processes only new data. So zero idle servers. That meets those constraints or those requirements from the question stem.
Nice.
All right. And the other ones, options two, three, and four, I notice that all of them require more hands-on management or always on compute. All right. Data Wrangler still spins up glue under the hood and needs flow management. Um, EMR clusters and EC2 scripts incur cost, continuous instance cost, and require patching.
Yeah, maintenance. Yep.
Yeah, maintenance, absolutely. All right, so let's keep going. Let's go move on to question number two. And so question number two is an online education platform is training an XGBoost model on 1 million student records. The team wants the most efficient hyperparameter tuning method to minimize total compute costs while achieving strong accuracy. Which approach should they choose?
All right. Good question. Let's see our options here. Option one is going to be SageMaker automatic model tuning using Bayesian optimization. Two, SageMaker automatic model tuning using the grid search. Three is going to be random search with manual resource allocation. And four, manual hyperparameter trials in SageMaker Studio notebooks. So looking at here, most efficient and minimize compute costs, we need to find something smart that is going to converge quickly. And then therefore, this leads me towards model tuning, right?
Yeah.
And then we have two choices here, Bayesian optimization or grid search. And I think Bayesian optimization is going to win because it learns from past trials to pick up the next best hyperparameter. And so there are far fewer jobs and therefore lower cost.
I agree with you. And yes, we mentioned those choices in a previous episode. Very cool.
Yeah, great. So let's maybe say why the other ones are not correct. So grid search is going to explore everything exhaustively, which is going to be more expensive. Random search can still be, wasteful if you're left handling. You might be left handling some of the resources there, and then manual trials are going to be too slow and then prone to human error as well.
All right. Too slow. That is our fate as humans, right? As
Yeah,
opposed
right.
to compared with AI. Okay.
Exactly.
Yeah. So always think smarter, not harder for tuning.
All right, great. One more, Aniakan?
Yeah, please.
Okay.
We have a couple more actually.
All
Yeah.
right, let's keep on going then. Question three. A startup ML model requires real time inference with unpredictable low volume traffic spikes. They want to minimize ongoing costs while guaranteeing real time responses. Which deployment option is the best choice?
Okay. So let's take a look at that. And I apologize. One more, like Ava said. Yeah. So these are the options. Okay. All right. So options. Option number one, SageMaker real-time inference endpoint with a fixed instance count. Number two, SageMaker serverless inference endpoint. Number three, SageMaker batch transform job scheduled every minute. And four, SageMaker asynchronous inference endpoint. So, yeah. And then we look at the qualifiers in the question stem, right? We see a real time, unpredictable, low volume. We see minimized costs. So, yeah, so and also this speaks to a deployment question. And option number two, serverless inference is perfect, right? It scales from zero. You pay per invocation. There are no idle instance charges, and you still get low latency,
Nice.
right? And then looking at the other options, fixed instances. No, we don't want that because we get idle costs. Um, Batch, even though it's every minute, it's not real time. And asynchronous endpoint, yeah, it still needs to be provisioned, and that is actually better for long running jobs. So yes, serverless is your real time cost saver here.
Very
All
cool.
right. Very cool. All right, Ava, let's do one more. So let me read this question. So a financial services firm runs a real-time credit scoring model behind a SageMaker endpoint. They need to detect daily feature drift with the least operational overhead and in the most cost-effective manner. Which solution should they implement?
All right, so let's look at our options here. Option one is going to be configure SageMaker Model Monitor continuous real-time monitoring. Two, schedule SageMaker Model Monitor batch transform daily jobs. Three, set up a CloudWatch alarm on inference latency. And four, develop a custom EC2 script to sample and analyze data daily. So let's look at some of the keywords here. Daily, least overhead, most cost effective. So this is clearly a monitoring question.
Mhm.
In a daily model monitor batch job, it seems to be spot on because it is automated. It can be configured to only run once a day, compares against the baseline distributions, and you pay only for that job.
So that's
So,
option two. Okay, that's
yeah.
okay. Cool.
So that's the correct option. And let's look at why the other ones are incorrect. Continuous monitoring is going to be too resource intensive in this scenario. Latency alarms track performance, not drift. And then custom EC2 script. This is going to be, frankly, a little bit of a maintenance nightmare.
Yeah, absolutely. All right, very cool. Thank you for that, Eva. So yeah, the AWS Machine Learning Associate exam is demanding. However, it's also fair. So focus on the practical implementation details that we've covered and remember to think like a solutions architect. You've got this.
Excellent. So, yes, you have put in the work, you understand the concepts, and now it's time to show what you know, folks. From both of us here, and Yekin and myself, we believe in you. Go crush that exam and let us know how it goes. Thank you, everyone.
Yes. Good. I love how you said that. It's time to show what you know. All right. All right. Thank you, everyone. Thank you, Eva, and thanks, everyone.
Thank you, Yekin. Thanks,
All
everyone.
right. Bye.